Hello everyone. So today we're going to be talking about something that's probably sitting right under your kitchen sink and you might not know that much about it. It's called sodium hypochlorite, and this is the science behind the solution. This presentation is brought to you by Bleachworks Studios, presented by Leanna Gonzalez. So you may know it better as bleach, but what is sodium hypochlorite? Well, there's a lot more to it than just getting rid of stains, or maybe causing them on your favorite clothes. It plays a crucial role in both biology, engineering, chemistry, really all disciplines, and it's been involved in life-saving medical advancements. From cleaning your bathroom to saving lives, this compound has a much bigger impact than you might realize. We'll barely touch the surface of how it works in everything from water treatment and chemical production to your immune system and how it fights infections. We'll also dive into the history very briefly behind its use in medicine and why it's still a key player in modern science and industries today. So stick around, because by the end of this video, I might just have cleaned up the confusion. Thank you. So let's start by talking about what it is. The chemical formula is NaOCl. That's sodium, oxygen, and chlorine. And this compound, when it's added to an aqueous solution, like water, it's dissolved and bleach is then formed. It typically appears as a pale greenish yellow liquid, though sometimes it can be quite clear when diluted and can kind of look like water. But it's widely recognized for its disinfecting abilities and its powerful smell, that clean smell. It's a strong oxidizing agent, which means it's highly reactive and it's capable of breaking down a variety of substances. So this is why it's such a go-to for cleaning and sanitizing in both household and industrial settings. So back to the chemical properties, it does react with a wide range of both organic and inorganic substances, so this is why it is such a strong disinfectant. When it's in its aqueous form, it's basic. It typically has a pH between 11 and 13, and this makes it effective for cleaning and breaking down contaminants. However, sodium hypochlorite is unstable under heat and sunlight, so when it's exposed to these conditions, it can break down and decompose into sodium chloride, possibly sodium hydroxide, and chlorine gas. So this decomposition, it not only reduces the efficacy of sodium hypochlorite, but it can also create safety concerns, especially with the release of chlorine gas. So we'll take a look at this study optimizing the antimicrobial activity of sodium hypochlorite, and the study focuses on how exposure time to sodium hypochlorite affects its ability to disinfect and eliminate salmonella from surfaces. So it was found that there is an optimal time of exposure, as well as other variables such as like concentration and things like that. They were able to find that the longer salmonella was exposed to sodium hypochlorite, the more effective the sodium hypochlorite was at killing bacteria. So this is really critical in food processing plants, healthcare environments, any setting where precise disinfection times can really help prevent the spread of harmful pathogens like salmonella. This is going to be really important and useful to know. So the research highlights the importance of understanding how sodium hypochlorite interacts with bacteria, and it also provides valuable insights into how to maximize its disinfecting potential in various applications. So it's quite obvious at this point that it has many applications in biology and health science, most notably in wound cleaning and as an antiseptic. Its strong oxidizing properties help disinfect wounds and eliminate microorganisms and prevent infection. So it's also used to disinfect surfaces, though, so not necessarily only in our bodies. It actually is used in a variety of disciplines, so in hospitals, healthcare settings. It's crucial to maintain a sterile environment, and so we need these tools and equipment to be free from bacteria and viruses. So the key to its effectiveness is its ability to oxidize microbial cell walls, which leads to destruction of harmful pathogens. So by breaking down these structures, sodium hypochlorite helps to ensure that medical tools, environments, and other things of that nature remain free of contaminants, and that ultimately protects patients and healthcare workers. So one fascinating application of sodium hypochlorite is in dentistry, specifically in root canal therapy. This was actually very interesting for me to learn that it's used as an irrigant in the mouth. You would think that any type of ingestion of this would be toxic, but it kind of goes to show that a lot of chemicals that we think to be toxic sometimes already exist in our body in some form or another. But back to the article, it just talks about how it's widely used as an irrigant. It's actually considered the gold standard because it's able to dissolve organic tissue, such as pulp remnants that remain in the canal after the infected tissue is removed. So it's essential for disinfecting root canals, especially when bacterial biofilms are present. These biofilms are actually often resistant to conventional treatments. So again, this sodium hypochlorite is considered the gold standard. Despite its strong despite its strong antimicrobial action, sodium hypochlorite does face some challenges. It does have limitations in its ability to thoroughly deep clean dentin layers, some of the harder to reach areas, but they are doing some ongoing research to continue improving and see how its application can be more effective in dental treatments. Again, quite evident, but it has applications in chemistry. Chemistry is a central science, so everything almost relates back to chemistry in some way or another, but it's a common reagent in redox reactions, so it's used in processes like bleaching, organic synthesis, and water treatment. So as you can see here, it has these various roles in chemistry. It notably plays a vital role in wastewater treatment. So it's used to eliminate harmful contaminants, including bacteria, from water to purify it. This makes it safer for our consumption and ultimately for the environment. So I wanted to include this book in my presentation because I actually picked it up when I was on vacation in a bookstore. It just spoke to me, and I just remember one part of this book that really kind of applies to the whole idea of sodium hypochlorite and its applications in various disciplines. So it's called The Song of the Cell. It's by Dr. Siddhartha Mukherjee. I hope I pronounced that correctly. But he draws many compelling comparisons between the biological roles of sodium hypochlorite and its everyday use in sanitation as well. So he highlights how in the human body, sodium hypochlorite is actually naturally produced by neutrophils. Neutrophils are a type of white blood cell in the system, in the human immune system, specifically used to fight infections. And these neutrophils, when they release this sodium hypochlorite, it actually releases reactive oxidant species, as he mentions, ROS. So like hypochlorite ions, these help break down bacterial cell walls. We kind of talked about that a little bit with the other articles. This is actually a really important part of how it is as effective as it is. So he also brings us back to a critical moment in medical history when earlier surgeons, like the early 19th century, before germ theory was established, they were not necessarily aware of how unsanitary practices led to infections and death. So surgeons would often drop scalpels on the floor and simply just wipe them on their white coats, continuing to work without any type of sterilization. So this lack of hygiene, as we know today, obviously is unacceptable, and it led to many deaths. And he actually says at one point that 1 in 3 women would die from infections following childbirth, just due to this simple lack of hygienic practice. So with the work of many pioneers and germ theory and disinfectants, we're able to move to where we are today. But those discoveries actually laid the foundation for modern antiseptic surgery, and it highlighted the importance of understanding microbial biology. So this led to many advancements in both medical practice and the use of compounds like sodium hypochlorite. It also has applications in engineering. We know that it's widely used for cleaning. This could apply to equipment in various industries, such as food processing and manufacturing. So those strong disinfectant properties are going to be really crucial in industries where hygiene standards are strict. We talked about wastewater treatment. It's definitely important where it's used to disinfect water and treat wastewater. It's effectively killing harmful pathogens, virins, bacteria, things that we would be otherwise consuming. So it's really important to note that this is affecting all of us. And beyond sanitation, it does serve as an oxidizing agent in various industrial applications, such as the manufacturing of chlorinated solvents, herbicides, and pesticides. I was actually interested in its application in odor control. We know that it has that smell clean, but it actually can break down organic matter and in turn, control odors. So it's incredibly versatile. It helps enhance, the reactivity, stability, and overall efficacy of industrial processes, all while, ensuring public health and safety. So there are concerns. Is it harmful? It does have many beneficial applications, but it is important to consider the potential for toxicity and other risks associated with improper use. So we kind of talked about root canal, its use in root canal surgeries. Well, when sodium hypochlorite reacts with organic matter, such as that in root canal treatments, it can actually generate harmful compounds, including volatile organic compounds, VOCs, and disinfection byproducts. So these substances pose health and environmental risks, especially if not properly managed. It can also cause irritation to the mucous membranes and the skin. You might have noticed this if you're ever cleaning and you get some bleach on your hands. It almost seems to suck all of the water out of your skin. So definitely see those oxidizing properties in that example. You could say that it's very effectively disinfecting your skin. That being said, the benefits of sodium hypochlorite, particularly in sterilization and disinfection, definitely outweigh the disadvantages, especially when handled properly. So careful usage, proper disposal, safety measures, all are going to be essential in mitigating the potential risks and protecting, our environment and human health. So to wrap it up, sodium hypochlorite is an incredibly versatile compound, from its critical role in disinfection and sanitation, whether that be in hospitals, water treatment plants, or even root canal treatments, to its use in industrial processes like bleaching and manufacturing. Sodium hypochlorite has far-reaching applications across multiple fields. However, it's important to remember that while its properties make it indispensable in many ways, we must be cautious about toxicity, the generation of harmful byproducts, and its potential environmental impact. So proper handling, exposure control, and disposal are crucial to ensure that we continue benefiting from sodium hypochlorite safely and effectively. So with that, I'd like to thank everybody for their attention. Before we conclude, I'd like to take a moment to acknowledge and thank those who made this project possible. A special thanks to Bleachworks Media Group, Paloma, Raphael, Leslie, and Nayeli. Thank you for your collaboration. Thank you to all the referenced authors. I would like to express my sincere gratitude for their dedication and enthusiasm toward research. We're able to learn a lot from their discoveries. And last but certainly not least, a heartfelt thank you to our chemistry professor, Dr. Kenneth Drake, for making chemistry not only accessible, but truly fun and always sparking our creative and curiosity along the way. If you have any questions or would like to connect, feel free to reach out to me at leanna.gonzalez@student.csn.edu. Thank you so much for listening, and on the next slide, you'll find the references.